Okay, so I don't actually want to go over like in depth every single problem. I want to just kind of go over the ones that you had questions on. I'm going to tell you the answers, and then I know that number 2 probably you have a question about, or most likely. So number 1, number 1 is D. Now number 2 is A. So I want to talk to you about how that came about and why it's A. You actually kind of needed to know the formula for that, and I don't expect you to have that formula memorized. So, you know, I don't know how you would have done this unless you looked it up in your notes. So, the formula for the standard deviation, which again, I would never have you don't have to have this memorized. It's on a formula chart. I just haven't given you formula charts yet because we don't know very many on it. So it's 1 divided by n minus 1 times the summation of your individual x minus the mean quantity squared. So if you remember the activity where we were all lined up and we were talking about the average height in here, we were talking about how far you were away from average, that's this. So you had your individual height and we were getting the difference between you and the average. So with that being the formula, let's look at what this says here. So this person, first of all, took 10 items. So what does that mean? N, which is the number of items, is 10. Okay. All right. And then calculated the differences. Okay. Here's what part that is. Here's the differences right there. Okay. That's xi minus x, the mean. Okay. And then she squared those differences. And so that's that part. Okay, and then that sum was found to be 218. So essentially, what you're saying is that summing all of this section here, and black that out and then draw on top of it. So all of that section right there came up to 218. It's kind of hard to see that, but that's 218. So if you have 218 in that formula, 218 right there, then now what are you going to do with that? Well, first, though, you need to divide by n minus 1. And how much is n minus 1? 9. So you take that 218 and you're dividing by 9, and that's how you get this 2422. Now that is the variance. That's the vocabulary word for that. It's what it is before you take the square root. So that 24.22 is the variance, and then when you take the square root, that's how you then get 4.92. Okay? So that's how you did that problem. You had to walk through the formula and understand the vocabulary of what was done there. Number 3 was C. Skewed right, centered about 4.5. Next, okay, number 4 is A, and 5 was told in the book to be B, but honestly, I think you can make a case for C as well, and I'm going to show you that here in a second, but let's talk about 4 real quickly. So, I needed to find out where the items were, like where the median was. That's what I found first. So, I could tell that I approximated how many items there were. It's like 47, 12. I actually kind of think my numbers appear to be a little off. That's probably 14. But anyway, in any case, I came up with about 66 items. So I approximated there to be 66 items. To me, it looks like it's probably more closer to 68, 70. So anyway, 68 items. So if you have 66 items, then that you have then 33 items in the first half, and then 33 items in the second half. Okay? So do you have a whole value for the median? Do you have an odd number of items in your set? No, I counted 66. So this is all of my items. So how do I determine this median? I need to average this last value here and this first value here. This is the 33rd item. This is the 34th item, so that puts it about right here. So there's the median, which is from 0 to 1. And then you can find the answer from there. Because the only one that had the median from 0 to 1 was answer choice A. Okay? Now, if you had more than one to do that with, I did go ahead and I approximated where the Q1 and the Q3 were, and so on. Q1 was in here somewhere, Q3 was in here somewhere. So they ended up, so Q1 was also from 0 to 1, Q3 was from 1 to 2. See? So they're closer there. So those were other ones to back up the fact that it's answer choice A. Alright, now on this one, how can I find Q1 for this one? Probably need to identify what first? Okay, median, but in order, before I even get median, I need to find out if there are 25 items. If there's 25 items, which item number is the median? The 13th. And so then you split this half down here, and the median is going to be between number 6 and number 7. Well, look at where this is. Item number 6 and 7, between item number 6 and 7 puts you actually somewhere right in between those two things. You know, because there's 6. So I have a problem with this answer because I think mathematically you could come up with either B or C. I mean, and I could elaborate on that. What if this number was 79 and the number from this group was 69? Where does that average put you? At like 74? Something like 75? I don't know. So, but at any rate, it's in this set. Okay, well, what happens if one number was 65 and the other number was, 70? Where does that put you? If you average those, where does that put you? It puts you in this set. So I have a problem with this answer. I would have accepted B or C because I think you can numerically achieve either one of those sets. Okay, next. Here we're pretty straightforward. Identifying the median. The largest is business leaders, but it's not on there as a choice, so it was scientists. Now look at this number 7. Here's an issue. The smallest IQR is not from 70 to 82. That's not the right answer. Because how do you find outliers? What's the outlier rule? 1.5 times the IQR. Well, how can you do 1.5 times from 70 to 82? Correct. So it's 12. So the IQR's value is 12. It's a number, not a range. Okay. It's a number that represents that range. And 8 is D. This one, the 10, cannot be represented in a pie chart. Why? Good, because if you total all of these up, it's greater than 100%. How could that happen? I want to know that. Okay, so an owner could pick more than one location that the dog rides, okay? So there you go. Here's me right here. Here's my girl. Now, questions on why D is correct. I did get that. D says that this difference here is exaggerated. Did you know that this is only twice the amount of this? But it looks like a lot more, doesn't it? The area principle is being violated because what's happening right here. Yeah, it's like skipped the 10 percentile. So this is only twice as much as the driver's lap, but it looks like it's more than twice as much because of the incorrect, it violated the area principle. Okay. Next, this page, the answers are A, D, B, and C. And so, questions on those?
I circled.
Are you sarcastic? Or you did? You did it right? Yay! Okay, yes, ma'am. Did you put? Okay. I agree. I mean, you can. You can make a dot plot from this information, and you could make a histogram with the class intervals of those. So technically, I think both of those are correct. So I know, but I don't know. I don't know why. I picked this one, and I guess the book because it was more specific with how it did those ranges. I don't know. But with the histogram, you could on the dot plot if they had like this. I guess. I don't know. I just think this is better. This is probably okay. I guess technically it could be happening, so I guess technically it could be right, but that is better. Yes. Correct. Same with so like you can tell the frequency on a histogram because you can tell how many items, just like you can tell how many items are in a dot plot. So they're both telling you the number of frequency. I just think I liked this part. All right. But how about 11? Are you okay with the computation on 11? Because you actually had to compute things. You had to count where the median was, where the Q1 was. Q1 is 3. Q3 is 7. So the IQR is 4. So here's how, so to find the fence, you did this, and that equals 13. So the upper fence is at 13, which makes 14 an outlier. The lower fence was 3 minus 6. So the lower fence was at -3, and you can't have -3 lobsters found, so you just had that one upper outlier. And 12 is a pure vocabulary problem for you to know that the variance is the square of the standard deviation. So you just had to square that standard deviation, and that's how you got your answer. All right. Take a look at these, 13, 14, 15. Ask me any questions. I hope that those were pretty straightforward ones that you could get. Okay, 13 is C, 14 C, 15 A. Notice how 15 is not represented as a percentage, it's represented as a decimal, and that's fine. Okay, Jesse. Well, hold on. The number of high school students taking an AP class in a subject or grade level. So you're saying that when it says of students, it implies of students taking AP. Oh, and then there could be overlap too, and so yeah, so it's probably just a bad example, like real world situation because of that. So okay. Thinking, yeah, I don't know, maybe. I have to think about it. That's like pretty much reading way into. Again, now think about this. I mean, get into the eyes of, or the head of the person that's making these problems. I mean, do you really think that I'm giving you all of these specific numbers and stuff to trick you and say, oh, you can't really find an answer because this is about just AP classes, not about all of them. All right. Yes, ma'am, Katie.
So on number 14, I thought it was out of the total amount of students taking
Yes.
and not out of the total. Not out of
No, what percentage? Okay, so 14. Yes, listen. Out. What percentage of the students? So that meant the total students
But it says that
are junior foreign language takers. So that's the junior foreign language takers out of students. So out of the all students, how many are the junior foreign language takers?
I thought it was juniors out of all of them.
No, because it says what percentage of the students. So it's out of all the students. Yes, ma'am. The intent is juniors and taking. So this is the conditional here of junior and taking foreign language. And out of, I don't know how to tell you, but anyway, that's what the language is intending you to read it as, so that's what it is. Okay, next, 16. They all three are true. Now, honestly, when I did this, I kind of was wondering what's going on with this. I felt pretty good that it wasn't an experiment. I guess I was kind of wondering, do you call a sample survey an observational study? And so here's what I thought. So here's how I kind of like reasoned out the answer page. So you guys ready? First, I could tell number 2 was good. Yeah, observational study is already existing situation. Like when I got that J.D. Power and Associates survey in the mail, then it was given to me because because we already own a Kia Sorrento or whatever. Okay, so basically the survey was the method of collecting the data. So that's the way in which you collected the data on the already existing situation. Okay, so the sample survey was the way that you got that data on that already existing. You did not impose a treatment. Survey is not a treatment that you're imposing. All right, and then also number 17, I have an issue with this one here because none of the above is correct, is true, because this is no good, this is no good, none of the above is, that's actually true because the first 2 aren't right. So I can tell you what happened on this, because this would have been a problem made by a test taking, or a test generator when it switches around the answer choices. And so the intent was that this was actually supposed to be the bottom one, saying that none of all of them are true. So that's, sorry about that confusion on that problem. So the answer is D, because the first was an experiment without a control and the second was an observational study. Okay? All right. Next. It is 1 and 3. 2 is wrong because you cannot do cause and effect from the observational study. And I guess having this relationship absolutely determined, not where you are inferring it. In order to know it for a fact, you would have to do a census. So what would end up happening with this is that you have a small population. Maybe this is just going to be about the milk that's in the cafeteria right now. Maybe the population is the milk in the cafeteria right now. I don't know. So there you go. 19 is E, because that was voluntary response. So it renders the information meaningless because it suffered from bias. All right, I want to talk about number 20 because this is an important thing to understand. And this took me a couple of times finding these kinds of problems to kind of fully get what it was saying. So let's look at number 20. So this problem is saying that here's the way they are sampling. They have 7 teams. So here's all the teams. Okay, and then they're going to get 2 from each team. Okay, they're going to get 2 from each team. And so that's how they get their 14. All right, so now, describe for me how a simple random sample would look. How would a simple random sample happen? Okay, good. You put all 84 players in a bag, and then you draw out, and shake well. Okay, shake, and then draw out 14. Okay, now question. When you do that, is it possible that you get, 6 from this team and maybe 5 from this team and 3 from that team? Is it possible to only have 3 teams out of the 7 represented? Absolutely. Every possible combination of 14 could happen. You could even have something really weird, which would be, maybe you get all 12 of that team and just 2 of that team. Okay, but here's the key. In a simple random sample, every grouping of 14 is equally likely. Okay, that's the definition of it being a simple random sample. Every grouping of 14 is equally likely. How about moving? Okay, so can that happen with this design? Is it possible to get any type of grouping of 14? No, because you can't get more than 2 from a team. So every possible combination of 14 is not equally likely. Therefore, it is not a simple random sample, and here's the language, because not each group of 14 players has the same chance of being selected. That's what that's meaning. Can't get all the different combinations of 14 as likely as the other, okay? All right, 21 is B. I knew 2 and 3 were correct. I did not feel qualified to know that 1 was correct. The book says the answer is B, but if you picked E, I could see that because I thought it was just 2 and 3. Okay? All right. Now, number 22, blocking. What do you do for blocking? Give me an example of blocking. You would block maybe by what? Male, female. Okay, so say if you block by gender, then you have just made everybody in the group all males or everybody in the group all females. So, these are homogeneous groups because they have all the same characteristic of gender. So then you're only comparing male against male. So that's called reducing variation. Homogeneous is like all the same. That is reducing the variation. Okay, so that's why that's that.
I thought it's 6 out of 4.
Control the level. I don't know what that is. The level of the experiment.
I thought it sounded good.
Okay. All right. Well, reducing variation is what it does because we're making homogeneous groups. To control, because then it controls the fact that gender might affect the way the medicine works. Okay, that's what you're doing, controlling extraneous factors. Okay, 23 is A. I was fine with that one being A. 24, I pretty strongly feel as though it's E, even though the book says B. So let's discuss it. I'm good with 3 being wrong. So let's talk about that first. 3 is wrong because 3 says, I think it actually sounds pretty good. It's kind of a subtle reason why it's wrong. So let's look. 3 says, use a single treatment. Okay, so that sounds good. That's like an experiment. To gain knowledge about the response variable. And my goal is not to just gain knowledge about the response variable. My goal is to see how the single treatment affects the response. So that's why I say 3 is wrong. Okay, hold on. But when it says use a single treatment to gain knowledge about the... Okay, I think this is also a wrong thing. In an experiment, yeah, if you do single treatment, do you have an experiment and just give everybody 1,000 milligrams of whatever? Right. You need to have something to compare it against, so that's another reason. So you have to have something to have a difference there. Okay. Now, 2 I'm good with. Hey, but I did want to remind you on the test, on the last test we had, or 2 tests ago, there was a free response that asked you about why you randomly assign. There's 2 reasons you randomly assign. Tell me one. What you randomly assign to the treatment groups. Okay, avoid bias. So I'm not imposing even subconscious judgment as to why I'm putting those into the groups. Okay, avoid bias. There's another reason. What is that? Yes, you are pretty much hoping that any kind of traits in the group, like height, weight, gender, whatever, gets sprinkled evenly into the groups, okay? So they kind of like cancel each other out. So that's the reason you do random assignment. Okay, so I had an issue with this one. The book did not say 1 is true, and I'm like, yes, it is. Anytime you go into an experiment, aren't you automatically thinking, okay, is there anything else that is, affecting this that I need to make sure that I control? Like when I do the plants and the fertilization or the fertilizer, do I put some in sun and some in shade? No, because that's a confounding variable. So I think that controlling slash eliminating, maybe the reason 1's not true because this should be eliminating. I don't know. But you need to think about your confounding variables and make sure that you are controlling them or eliminating them as much as possible. So anyway, there you go. E or B. Book says B. I think you have to control those things. So here comes our free response. This is an actual free response AP in 2008. So this is what I'm telling you, people, that when I say you have to know the mechanics of making a box plot, it's because if you couldn't do that on this, you had no credit on this problem. I mean, it was all about creating a box plot, understanding outliers, and then understanding the interpretation of it. Okay, so here we go. I just took each additive separately. I did all the information for additive A, all the information for additive B, and I found their outliers with the 1.5 IQR outlier rule. Okay, so for the upper outlier, I found on A, it had an upper outlier at 8.5. So look at this data here. So here's 8.5 mark right here. So what does that tell me about 9? 9 is going to be represented by a dot because it is an outlier. Okay, 9 is a dot because it's an outlier, and therefore tell me what's going to happen with 7. Your whisker will go to 7 because that's the next one in, and then you have a gap. And you have a gap, and then the dot. Good. So let's do the lower outlier fence. When I do that for A, the lower fence is at -3.5, so that is here. So I look at these values. Here is the lower outlier fence at -3.5. So 8, -8, and -10 are outliers. And then what happens with the -2? That's where my whisker goes to. All right. So then I did the same process on B. Tell me something interesting about the IQR on B. It's big. It's very big. So it's a lot more varied data, isn't it? In fact, you ended up not having any outliers because the fences were like crazy out here because you had a big IQR. IQR was 27. So when you multiply 1.5 times that 27, that really pulls the fence way out there. So you had no outliers for B. You had 3 outliers for A. You had 2 lower ones and 1 upper one. Okay. Now, C. You actually could choose either answer as the best additive if you supported it and used comparative language, higher than, more consistent, less varied. Okay, so did you make a choice and use comparative data that supported your choice? I said that this upper 75% is greater than this bottom 25%. The median, anyway, it's much more consistent. A is much more consistent. B is much more varied. But you could make a case for B. Did anybody choose B? Yeah. And what was your case? Yeah, you had some higher values. I mean, this one's like crazy a lot more higher than this one. And A also had some of the lowest ones. Okay, so if you used comparative language and you made a choice, then you got your credit for that part. Okay, so that's that one. Now, when I was going around today, let's look at the details as I was stamping today that I saw missing on your experimental design. So here we go. This first one says you need a completely randomized design. So don't block. Okay, just completely randomized. So don't forget to write randomly assigned. And don't forget to tell me how you accomplish that randomness. That's important. How you accomplish that randomness. So I put all the names of the 80 patients in a bag, and yes, shake well, but hey, do not leave those 80 names in the bag. Okay, don't stop right there. Say, pull out 20 names for each group. All right, so I would have given you credit. So here's how I kind of would have divided up credit. That would have been credit. Of course, doing these treatment groups, that would have been credit I was looking for. This is probably the next most missed thing. Okay, this is important, and I think honestly, I didn't really stress this when I first taught you it, but I have come to realize that this is something that's getting missed out on. This says measure skin disease improvement for each group. Okay, in the realm of an experiment, what's the vocabulary for what I just boxed in? What is that concept called? It's called the, I hear something. Yes, very good. This is the response variable. If you do not write this in here, then another person cannot reproduce your results with the experiment because they do not know what to measure. They have to tell them what to measure. And then, of course, compare those things at the end. All right. Now, here, it was determined that the skin type, maybe the melanin in the skin, has an effect at which the rate of the skin condition clears up. So therefore, you wanted to control that situation. So the first thing you're going to do is block. Do not randomly assign first. Block first. Control first. And tell me how and why you control. Look here. I will block by skin type because that may have an effect on skin improvement rate. If you do not have this, it may have an effect on skin improvement rate, then that's not correct. Then it's wrong. Because skin type can affect the rate. So I don't want to compare a whole bunch of light-skinned people in a group against a whole bunch of medium-skinned people in a group because they have different amounts of melanin in their skin, which could affect the rate at which the skin condition clears up. All right. Now, after blocking, then you randomly assign. So when I have them into these 4 treatment groups, I have a question. Tell me about all the people in these treatment groups. They all what? They are all fair skinned. So I'm only comparing fair skinned people against fair skinned people, so their skin types are the same. All right. And then measure the skin improvement and compare. Don't forget, put all fair-skinned subjects in a bag and shake well. Now don't leave them in there. How many am I going to put in each group? I don't know the exact amount because I do not know how many people of my 80 were fair-skinned. So I'm going to put, oh, I messed that up. Then I'm going to put a fourth right here, a fourth for each treatment group. So I could write that here, a fourth, a fourth. I like coloring on it, detail. A fourth, okay? So, because I don't know exactly how many that is. Don't tell me that's 10 people or whatever. All right, that's what, and then I put follow the same design as above for each of the blocks because I did not want to have to write that again. You can do that. Repeat within each block. Yes, ma'am.
Would you write for each block before we do any design after we do?
For each block, yes. Within each block, do this. Yes. Okay, so there's your review. And so that's pretty much it of what you have. 7-week cumulative stuff of all the things you have learned. And then you have your test tomorrow. I don't